Welcome to This Explainer. Today, we are unpacking a truly revolutionary theoretical framework. We're looking at a model that attempts to do nothing less than decode the entire universe using just a single mathematical fraction. I know, it's an absolutely massive claim, and we're going to break down exactly how this framework attempts to completely rewrite our understanding of reality. Okay, let's dive right into this highly dramatic hook. 7 over 192. How could this single, dimensionless geometric ratio possibly replace Albert Einstein's entire framework of continuous spacetime? Well, according to the source documents we're analyzing today, this specific fraction is what's known as the master scalar. It's not just some random number pulled out of thin air. It's a pure combinatorial geometry ratio derived straight from the way microscopic networks connect and overlap. And the architecture claims that from this one fraction, literally the rest of physics simply emerges. But to really wrap our heads around this, we first need to define the framework itself, unified dynamics. Now, standard physics generally treats the universe like a smooth, infinitely divisible sheet of rubber. Unified dynamics fundamentally disagrees with that. It argues that at the most fundamental level, space and time are strictly pixelated. They are made of discrete combinatorial units. So instead of a continuous painting, imagine reality as a high-resolution digital screen. Everything, absolutely everything, is built on a finite, countable grid. And this comparison brilliantly illustrates the core conflict between the old guard of physics and this new theory. Notice how standard physics relies on somewhere between 19 to 26 arbitrary tuning parameters. These are basically fudge factors like the mass of an electron or the strength of electromagnetism that we just have to measure in a lab and manually plug into our equations because the math itself can't predict them from scratch. Unified dynamics, on the other hand, operates under what the sources call an epistemic quarantine. It point-blank refuses to use any arbitrary tuning parameters at all, zero. Its goal is to generate everything deterministically from that basic pixelated geometry we just talked about. So, let's move into part 1, the origins of mass and gravity. If there are absolutely no arbitrary numbers allowed, where do the heavy hitters of physics, like mass and gravity, actually come from? Well, as detailed in this quote from the source text, mass isn't just stuff. It's not some magical substance floating around in the void. Instead, mass is defined as an accumulated topological defect. Imagine a perfectly flat, pixelated grid. Now, imagine a knot or a localized burden physically trapped within the connections of that grid. Mass is quite literally a measure of that structural deviation forced into the closed internal boundary of the network. It's essentially an error in the geometry that the universe just has to carry around. Which brings us to how the universe actually moves forward, a process the framework calls causal unrolling. Before anything exists, there is a null state, absolute nothingness. But in this specific math, absolute nothingness actually causes a division by zero error, a capacity singularity. To fix this, the system mathematically forces itself to update. It executes a first causal tick, which generates a basic geometric projection space. As these discrete sequence ticks accumulate, we experience and measure them as time, and as the boundaries of this network expand to handle those internal geometric defects we just mentioned, we measure that expansion as spatial length. So, time and space, they're really just byproducts of the network updating itself.
And that leads us to a pretty stunning redefinition. In standard physics, the speed of light, or c, is treated as a cosmic speed limit for moving matter. But in this pixelated universe, c is something much deeper. It's the strict, one-to-one operational parity between a time update and a space update. For every single discrete causal step the universe calculates, the observable projection expands by exactly one discrete edge. The speed of light isn't a speed limit at all, it's the fundamental synchronization gear between time and space.
Now, because this internal structural burden, what we experience as mass, must be projected outward into observable space, the theory deterministically calculates the gravitational constant. And the crazy part, it does this without any measurements whatsoever. By calculating the specific geometric cost of embedding that internal defect into an outward-facing boundary, it arrives at exactly half of our master scalar. The gravitational constant emerges mathematically as exactly 7 over 384. Gravity isn't some mystical attractive force here. It's just the structural capacity required by the grid to encode trapped information.
Let's shift gears to part 2, the holographic falsification trap.
You see, a theory is really only as good as its testability. Unified dynamics explicitly constructs what it calls a terminal falsification resolution matrix to literally prove itself using the limits of data density. Instead of hiding behind invisible fields or extra dimensions we can't even measure, unified dynamics makes a bold, mathematically rigid claim. It targets the absolute maximum information a region of space can store, which in physics is known as the Bekenstein-Hawking entropy bound. By applying its master scalar directly to black holes, the framework maps its exact internal math onto the observable physical universe. And the contrast with standard physics is just striking. General relativity, the old continuous model, predicts that event horizons are perfect, smooth membranes that absorb everything seamlessly. But unified dynamics insists that because reality is fundamentally pixelated, the universe's true data capacity hits a hard, discrete ceiling much earlier than Einstein ever predicted. When we map that 7/384 gravitational offset into the holographic entropy bound, we get an exact, discrete limit scaled by exactly 96/7.
Which leads us to part 3, the black hole horizon test. The narrative gets really tense here because we're approaching the absolute climax, actually testing this bold claim at the cosmic scale of binary black hole mergers. The framework puts all its chips on the table with this specific number. It predicts an exact 1.8% amplitude deviation in the ring-down phase of merging black holes. Think of it like this. When black holes merge, they essentially ring like a struck bell before they finally settle down. Because of the discrete topological boundary limit we were just talking about, unified dynamics dictates that this ring-down simply will not perfectly match the smooth decay predicted by classical general relativity. There absolutely must be a roughly 1.8% deviation.
Mechanically, this makes perfect sense within the model. Because the black hole horizon is a pixelated grid with a hard capacity limit, it just can't smoothly absorb all the high-energy perturbations. This boundary ends up acting like a partially reflective membrane. As a result, those higher frequency overtones are measurably suppressed, and trapped modes bouncing against this boundary generate faint, delayed periodic gravitational wave echoes.
So you're probably asking, why haven't we seen this yet if it's so incredibly precise? Well, current detectors like LIGO and Virgo operate with a signal-to-noise ratio somewhere between 10 and 30. At that resolution, trying to pull an exact 1.8% deviation out of the instrumental background noise is statistically indeterminate. The theory is currently insulated by the limits of our own technology. To prove this, we need next-generation, third-generation interferometers, like the proposed Einstein Telescope or Cosmic Explorer, which will operate at a signal-to-noise ratio greater than 100. That right there is the threshold where this theory can be robustly tested and potentially completely falsified.
So right now, the entire unified dynamics architecture, having fully mapped its internal math to this one specific physical prediction, is effectively frozen in cold storage. The source documents actually state it has entered a passive observational hold. The math is done, the predictions are permanently locked, the theory is now literally just waiting for the physical universe's hardware to catch up to the math so we can finally measure the ring down of a black hole with enough clarity.
Which leaves us with this final, massive stake. When the Einstein Telescope powers on and captures a black hole merger at high resolution, what exactly will we see? If it finds that 1.8% deviation in those predicted echoes, it will confirm the pixelation of reality and completely rewrite the very fabric of physics. But if the data smoothly matches Einstein's old continuous equations, this entire architecture and the beautiful 7/192 scalar that built it will be empirically destroyed, reduced to nothing but a fascinating mathematical ghost. It's a waiting game now, and the stakes honestly couldn't be higher.